welcome to other types of methods and this keyword. So in this lecture, as you can tell by the title name, we'll be looking at a couple of different types of methods. So far we've learned about how to declare methods, and we've learned about constructor methods, and now we're going to be looking at some of the other different types of methods. So we're going to be looking at the getter and setter methods, static methods, which we've gone over mostly already, and then we're also going to be looking at overloaded methods. And as we talk about these methods, we'll also go over the this keyword. So let's start off by taking a look at the getter methods. These are also known as accessors. So what these getter methods do, as you can tell, they get something for you. So they return object information without altering the object. So if I wanted to, let's say we have a person class and I wanted to get their name. So one of the methods maybe within this person class could be public string get name parentheses. So public because it's accessible to all, string because this will return a value of a string, and then it's going to get name is the name of the getter method. And as you notice, it starts with the word get. That's a fairly common thing for getter methods. They write get and then whatever you're getting, and then there's no arguments because it's simply getting the name, so it's just giving the name of whatever of the person class. So then it's gonna be, and then in the body it says return n semicolon. So this is assuming that n is a private instance variable which stores the value of the name, and that's within the person class. So even when, let's say that we have a private instance variable n, so that means any objects or any external programs cannot access n directly. So in order to get the value of n, they can call the public get name method, and then they can get the value of n. So that's how you can do it. So that prevents them from being able to modify the value of n, but they can still get the value of n. And then once this method is part of the person class, and remember the person class will have a variety of parts, a variety of methods, and a variety of instance variables. This is just one of the method. Of course, the person class will have a constructor and a constructor with a parameter where it takes a string and things like that, but we're focusing on this method because this is a getter method, also known as an accessor method. And now let's take a look at a declaration in an external class or an external program. And we'll say person Sam equals new person in parentheses and quotations Sam semicolon. So this is similar to how we're used to creating an object of the class, of a class in an external program. So person is the type, it's type of the person class. Sam is the name of this object reference or variable that refers to the person object, and new is a keyword, and then person in parentheses Sam. So we're using the person constructor, and in this case it's the person constructor with that takes in a string with a string parameter, and in this case we give an argument of in parentheses Sam. So that's the string we're getting. And as we can probably tell, the person constructor that takes in a string parameter would probably set that string parameter as the value of n that represents the name of the person. So let's say that when we create this object, person object Sam, we'll say that it has a private it has an instance variable n which has a value of Sam, and n is to be is indicating the name of this person object. And then if after that we could use the Sam dot get name in parentheses semicolon. So what this is doing is we're referring to this person object Sam, so Sam dot get name. So now we're referring to a method within Sam, which is get name method. And in order to get the name, in order to do the get name with the get name method, we get returned the value of n. So let's we've seen this before. So when we declare scanners, you remember that we declare a scanner as s, and then later in the program we'll say s.nextInt. And what this does is this it reads the next integer and returns its value. So similarly, we can using the dot operator. So as you can see, between Sam and getName, there's a dot operator, and that indicates that the getName method is part of the Sam variable or the person object. So what we do is whenever you want to call a method that is part of an object and you have a object reference, or you have a variable that represents the object which contains that method, you can put the variable name or object reference dot the method name, and then within the parentheses parameters if there are any. And see the call sam.getName would return Sam, because that's the value of n. Next, let's look at the setter methods or the mutators. So we know a way to get the method, we know a way to get the information, but we also need to establish a way to set some information, so if you want to change it. So what the setter method does is that it changes instance variables of an object, so it can change the values. So with the getter methods, we got the values of an instance variable, and with the setter method, you can change the value of an instance variable. So our sample setter method would be public void set name in parentheses string n. So this would also be part of the person class, and public so that it's accessible to all external programs and objects. Void because there will be no return type. This will simply just change the value of the instance variable, but it won't return anything. And then set name, and in parentheses string n. So string n is the parameter because we want the user to give whoever's using the program or an object to give us a string, and then that's what will set the value of the n instance variable to. And set name is the name of the method, and similarly to get name, it starts with set because it's a setter method. And then in the body of the set name method, we'll go this.n equals n semicolon. So as you can see, we know that this brings up a little bit of a problem, because what's happening is the name of the instance variable, the private instance variable, is n, and the name of the parameter is also n. So how will the computer will not be able to distinguish between the two different the parameter and the instance variables because they have the same name. So what we do in this case is we're using the this keyword, and the this keyword indicates that this.n, that represents the instance variable of the class. The this keyword indicates that whatever is followed by it is part of the class itself, and equals n. So then once the computer knows that the first n is part of the private instance variable, the computer also knows that the second n, it represents the parameter. And as you can see, we're using the dot operator again, so this dot n, so that's saying the n instance variable is equal to n semicolon. Now, one thing that you should notice that's good to avoid is to avoid having the same name for a instance variable and a parameter. It's helpful to avoid using the same name because that can create a lot of confusion, and you often may forget the this keyword. But in situations where you need it, you can use the this keyword in order to indicate which is part of the class and which is not. And then once we've used this set name, basically what the set name does is that it sets the value of this it sets the name value of n to be able to the string that the user gives. So let's say that we declare a variable named Sam of person type, and it's basically a person object, and it's we've created a object out of the person class, and that object is referred to as Sam. So person Sam equals new person in parentheses Sam. So Sam is a person object with an instance variable n of value Sam, a string instance variable n with the value Sam. And now let's say that we want to change the name of Sam. So what we would do is we do sam.setName in parentheses Bob. So again, we're using the dot operator, so we're referring to the Sam, which is the person object. So the object dot the method that we're running with the argument in between. So what this does is we know that we're referring to the object referred to as Sam. We're calling the set name method of this object, and we're putting in our argument as a string with the value of Bob. So what this does is that when the computer computer interprets this sees that we're calling the set name method in the person class, and we're saying that that the string n, which is the parameter, that's equal to Bob. So basically, it's becoming this dot n equals Bob. So basically, we're changing the value of n, which was originally Sam based on the constructor method call, now to a value of Bob. And as you can see with that, we've changed the value of the n instance variable. And we've used the dot operator again to refer to a method of a specific object, and we've used an argument Bob in order to fulfill the parameter requirement, and we're calling the set name method. And remember that the set name method is an example of a mutator. So now let's take a look at static methods, which we've actually already taken a look at already, but we'll look over them again because they're a critical part, and we've seen them in some of our programs already. But static methods are also known as class methods, and what they do is they give you no reason to need to create an instance of a class, or basically create an object. So as you've seen in the previous, we've been creating a Sam variable, which is an object reference to a person object, and we don't need to do that with a static method. So as you can see, the set name and the get name, they're not static methods because they don't have a static keyword within their declaration, and that's why we can't call these methods within our class. We have to create an object of the class in order to call these methods. And the thing about static methods is they don't modify the instance variables, or modify, so like for example, the setter method does modify the instance variables, and that's why it cannot be a static method. And instance methods, which we've looked at the setter method, the getter method, and the constructor method, and these are all examples of instance methods, and these are used by the object. So the object of the class uses these methods, and then the methods that the class uses are static methods. So the static methods contain the static keyword, and they're things that the class will use itself, and that it's meant for the class to use. So we've already looked at these, and we've seen them in different programs where we're not creating an object of a class and we still want to run some methods within that class. Next, let's take a look at overloaded methods. So overloaded methods are basically two or more methods that have the same method name, but they have different parameters. So this gives options and variety for the client. And if you remember earlier, I spoke about when we were talking about constructors, I mentioned that we could have more than one constructor, and one constructor that didn't take a parameter and one constructor that took a parameter, and that's actually what overloading is. So overloading is within a class declaring multiple methods with the same name but different parameters, and this gives option variety. So sometimes the client could have an argument for a parameter, and sometimes it couldn't, so it gives more variety. So next we're going to take a look at an example of an overloaded method. So here's an example of an overloaded method example. So within any class, there's no name for this class, we're just looking at the methods. So we have public int calculate, and the parameter is int x. And then we have public int calculate, and the parameter is int x comma int y. So what this is doing is that this is basically these methods are the same part of a class. They're both part of the same class, and they have the same name. So it could be, you could think that the computer would get confused. But the thing is, they have a different signature. So a signature is known as a combination of the method name as well as the parameters. So as you can see, the first method has a name of calculate, and it only has one parameter, int x. But the second method has a name of signature, has a name of calculate, and has two parameters. So because the parameters are different, both methods have a different signature, and therefore it's fine. These are known as overloaded methods because they have the same name but different parameters. And then when, let's say, of whatever class this is, if an object of this class were to be created and the client were to refer to the calculate method, then if the client put only one argument in the parentheses, or one integer in the parentheses, and didn't put a second one, then the computer would know to run the first method. But if, let's say, the client said whatever object name dot calculate in parentheses 2 comma 5, then because there are two arguments and fulfilling two parameters, the computer knows to use the second method, which contains two arguments. So that's the point of overloaded methods. The point of overloaded methods is to give more flexibility and variety for the client so that they can have more flexibility when calling methods. And today we've looked at a variety of methods and the disk keyword, the dot operator, and we've seen the different uses of them, and now we're going to combine everything, all the different types of methods into one program, and we're going to be taking a look at some hands-on programs to see how these methods fit in and what their structure is within objects as well as classes.